previous lecture, I have explained the concept of mixed strategy. The same problem we are going to continue in this lecture, but I am going to solve the mixed strategy problem in the perspective of player B. So, the agenda for this lecture is solving the game theory problem in B's perspective. Then I am going to explain some dominance rules in game theory. The probability of playing B1, strategy B1 is called PB1. I am going to assume that this is PB1, PB2, PB3. So, PB1 equal to the probability that company B selects strategy B1, PB2 that the company B selects strategy B2, PB3 the probability that company B selects strategy B3. Based on these probabilities, for a company's B's mixed strategy, what happens if the company A selects strategy A1? Okay. If the company A go for A1, what happened to the B? Using the payoff table in the A1 row, company B will experience a decrease in market share of 4% with the probability of PB1 and a decrease in market share of 3% with the probability of PB2 and a decrease in market share of 2% with the probability of PB3. So, if the company A selects strategy A1, the expected value referred to as company B's expected loss if strategy A1 is selected can be written as, so expected loss when A1 strategy is selected equal to 4 PB1 plus 3 PB2 plus 2 PB3. Like this, I can write for other. For example, if the company A go for A2 strategy, what is the expected loss for company B? So, minus PB1, I am writing here PB1, PP2, PB3. Okay. If the company A selects A3, what is the expected loss for company B? So, that will be 5 PB1 minus 2 PB2 plus 5 PB3. Let us show how company B can use linear programming to find its optimal mixed strategy. So, our goal is to find the probabilities, that is PB1, PB2, PB3 that minimizes the expected loss, because we know company will play this strategy, that is called Minimax. What they do? They will try to minimize the maximum loss. Okay. So, that minimize the expected loss in market share to company B regardless of strategy selected by company A. In effect, company B will protect itself from any strategy selected by company A by being sure its expected loss in market share is as small as possible, even if company A selects its own optimal strategy. Given the probabilities PB1, PB2 and PB3, game theory assumes that company A will select a strategy that provides the maximum expected loss for company B. So, the company A will look for maximizing the loss for company B. When company A selects its strategy, the value of the game will be the expected loss, which will maximize company's B's expected loss in the market share. Company B will select its optimal mixed strategy using Minimax strategy to minimize the maximum expected loss. So, the objective function is written like this: minimizing the maximum loss. So, this portion's maximum loss is company A will try to maximize the loss of company B, but company B will try to minimize its loss because it is Minimax. Now, we are going to introduce another variable, decision variable called loss B. So, define loss B to be the optimal expected loss in the market share for company B. because company A will select a strategy that maximizes this expected loss. So, we know loss B is equal to maximizing these losses. Thus, the individual expected loss EL A1, EL A2 and EL A3 must be less than or equal to loss B. If the company A selects strategy A1, so EL A1 should be less than or equal to loss B. The complete linear programming problem for B's optimal mixer strategy is like this: minimize loss B. So, constraints are less than or equal to loss B. So, what is the meaning of this one? If the company A go for A1, okay. So, company B will try to minimize the loss, okay. That is why it is less than or equal to. The company A go for A2, okay. The company B will try to minimize its loss, that is why it is called less than or equal to. So, now I have brought the linear programming formulations for comparison purpose into the same slides. So, in the player A's perspective, player B's perspective. In player A will follow maximum strategy, player B will follow minimax strategy. For player A's perspective, maximizing gain A, here minimizing loss B, okay. Here the constraints are greater than or equal to, because if the company B go for B1, company A will try to maximize its gain, that is why it is greater than. So, company B will try to minimize its loss, that is why it is less than or equal to. So, when I solve the LP model for B's perspective, this was the answer. So, the final value is 2.375. We got PB1 0, PB2 0.375, PB3 0.625. I am going to solve this linear programming problem in Excel. So, I have entered the decision variables, coefficient objective functions. So, when I go to solver, so say it is a minimization type. So, the objective function is your C8. So, the constraints are less than or equal to type. So, when I solve it, so the value of the game is 2.375, PB1 is 0, PB2 is 0.375, PB3 is 0.625. Expected loss for B for the strategy is chosen by player A. We got the value of the game is objective function is 2.375. So, PB1 is 0, PB2 is 0.375, PB3 is 0.625. So, what these three equations says? The expected loss for player B if the player play with A1 strategy is 2.375. Expected loss for player B if A chooses A2, 2.125. Similarly, expected loss for B if the player A plays A3. We know that player A will try to maximize, player A will play a strategy that will maximize player B loss. So, out of these three, so player A will go for A1 and A3 because these two strategies will provide maximum loss, but we know that player will try to minimize the maximum loss. Company A will maximize company's B's expected loss by selecting either strategy A1, A3. However, company B has selected its optimal mixer strategy by minimizing this maximum expected loss. There are two maximum expected losses, but the company B will try to minimize this maximum expected loss. How they will minimize? By playing PB1 0 times, PB2 37.5 times, PB3 62.5 times. So, thus company B obtains an expected loss in market share of 2.375 percentage regardless of the strategy selected by company A. So, the mixed strategy what we are recommending to company B is they should not play PB1 strategy. The PB2 strategy should be played 37.5 percentage of time. PB3 strategy should be played, that is a B3 strategy should be played 62.5 percentage of time. So, the expected loss is 2.375 percentage, which is better than the company's B's pure strategy B2, which provides 4 percentage loss. So, you see that there is a 4 percentage loss. Now, the loss is only 2.375. So, the optimal mixed strategy solution with the value of 2.375 percentage is an equilibrium solution. Given company's A's mixed strategy probabilities, company B cannot improve the value of the game by changing PB1, PB2, PB3, we have seen that. Likewise, given company's B's mixed strategy probabilities, company A cannot improve the value of the game by changing PA1, PA2 and PA3. In general, the solution to the linear program will provide an equilibrium optimal mixed strategy solution to the game. Some of the observations. First of all, consider the dual value for constraint 2 in the solution of the company A linear programming problem. So, I have brought the result of our linear programming model for the player A's perspective. So, the dual value is minus 0.375 percentage, minus 0.375. Recall that the constraint 2 provides company's A's expected gain if the company B selects strategy B2. So, the absolute value of this dual value, okay. So, the absolute value of the dual value is company's B's optimal probability for this strategy. So, what we are inferring, this is the output when we play, this is the output when we solved for this problem in A's perspective, but at that time we are getting dual value. So, the absolute value of this dual value is say for example 37.5. So, this is the optimal probability for the B strategy, company B strategy. We know that PB2 is 0.375 without having to solve company B's linear programming problem. So, we can solve in A's perspective, then we can see what is the dual value. So, that dual will be the optimal strategy for player B. So, using the absolute value of dual value for company A linear program in figure, we know that the optimal mixed strategy solution for company B is PB1 is 0, see this one, PB2 is 0.375, we have to consider only the absolute value, PB3 is 0.625, that is the important observations. Therefore, when a 2-person zero sum game has a mixed strategy, we only need to solve the linear programming problem for one of the players. Whether you solve the problem in A's perspective and B's perspective. So, when we solve the problem in A's perspective, you will get the result for the B's perspective also. So, the optimal mixed strategy for the other player can be found by using absolute value of the dual values. Now, the negative value of mixed strategy game. Now, when you look at when you are solving the problem, we got the positive value. What will happen if it is a negative value for mixed strategy? Consider a 2-person zero sum game where the payoff table contains several negative payoff for player A. It may turn out that when player A selects an optimal mixed strategy, a negative value of the game is the best player can do. In this case, gain A or loss B would be a negative, which causes the linear program to have infeasible solution. So, how to handle this when the value of the game is negative? So, what we have to do? Procedure to modify the negative value of mixed strategy game. So, define a constant C as follows. What is the C? C equal to the absolute value of largest negative payoff for player A. So, now a revised payoff table can be created by adding the C to each payoff, turning it into an equivalent 2-person zero sum game. Because the revised payoff table contains no negative payoff, the non-negativity constraint for the value of the game will be satisfied and a feasible solution will exist for linear programming problem. More importantly, the optimal mixer strategy using the revised payoff will be the same as the optimal mixer strategy for the original game. By subtracting C from the optimal objective function value for the game with the revised payoff, you will obtain the objective function value for the original game. So, this is the way to handle that if the value of the game is negative. Some more observations. The analysis of 2-person zero sum game begins with checking to see whether a pure strategy solution exists. If the maximum of row minimum for player A, say for example VA, is not equal to the minimum of the column maximum for player B, for example VB, the pure strategy solution does not exist. Okay. At this point, we can also conclude that a mixed strategy solution is optimal and the value of the game will be between this VA and VB. We have seen in our problem also. For example, in our mixed strategy market share game, the maximum of the row minimum is 2% and the minimum of column maximum was 4%. Okay. So, the optimal value for the mixed strategy we got in between 2 and 4. Thus, we can conclude that mixed strategy solution exists and that the value of the game is between these 2 and 4%. Okay. We would know this result before solving the mixed strategy linear program. Now, I will explain the concept of dominance rules in the game. In a game, sometimes a strategy available to a player might be found to be preferable to some other strategies. So, such strategy is said to be dominate the other one. This concept of domination is very usefully employed in simplifying the games, thus helps in finding solution to the games. So, when you use the dominating strategy, we can simplify the problem. I have taken one example. Notice that in this table, every element in the second row, this one, clearly A shall never play A3 because in the second row values always greater than the A3. A shall never prefer to play A3 because in comparison to this strategy, it shall be better off by adopting A2 regardless of what strategy is adopted by B. Thus, A3 is dominated by A2, hence it can be deleted. So, this is not required, anyhow we are not going to play this, because when we have to compare element wise, the A3 is smaller, A2 is larger. Now, I removed that. From the reduced matrix, observe that the first column here, values are larger, the first column values are larger than the counterparts in the third column here. Since B would like to minimize the payoff to A, it would always prefer to choose B3 to B1. So, the strategy B1 is dominated by strategy B3. So, we can remove this B1. So, after removing, the final matrix is -8 -2 7 3. This can be used for finding the value of the game. In this lecture, I have explained the concept of game theory in the player B's perspective. After solving the problem in B's perspective, I have compared how the same problem can be solved in A's perspective and B's perspective, then we have come to know that both are same. After that, I have explained the concept of dominance rule. So, the dominance rule is used for simplifying a larger game theory problem into smaller one. Thank you very much.